So here's a quick review on exponent rules. You've covered this in 7th, 8th, 9th, and at least 10th grade. So the product rule. The product rule means that anytime we multiply numbers with the same base, we add their exponents. To make that a little bit easier to see, we're going to use some numeric values. So x squared times x to the fourth can be written as x squared times x to the fourth. And if you count how many x's are listed, there are 6. If you add up the 2 and the 4, you also get 6. So it's x to the 6th. Now a power raised to the power is exactly that. You'll notice it's x to the a to the b power. So notice there's only one x there. Now look at the example that I gave you. It says x squared to the fourth power. It looks very similar to the top, but the top one also has an additional x. You have the parentheses, which mean that we have a quantity. So we have x squared quantity to the fourth power. That means we have it once, twice, 3 times, 4 times. That's x to the 8th. Quotient rule, we have x to the a divided by x to the b. That means when we simplify, we're subtracting the top number from the bottom. To make it a little bit more obvious, we are going to expand it. X to the 5th is x 5 times divided by x squared. And then what we're going to do is we are going to cancel out like terms. So we have x squared and x squared, 1 on the numerator, 1 on the denominator, and we can simplify. That gives us x to the third power. Again, notice that the top problem, oh no, that's good. Another way to look at it, or another example, is to look at a exponent, negative exponent. So here we have x to the negative a power. So keep in mind that negative exponent means that we are going to take the reciprocal of that base. So if you look to the right, it says x to the negative a power. That's equal to 1 divided by x to the a. So notice, we use the negative exponent to flip it, and then after you use it, the whole thing becomes positive. So let's look at 2 numeric examples. X squared divided by x to the 5th. Again, we broke it down by x's, and we are going to simplify. So x divided by x is 1, and x divided by x is 1. We are left with 1 divided by x to the third power. If we look at the same exact example, by using the quotient rule, the one where you're dividing, what we're doing here is we're doing x to the second divided by x to the fifth. So if we subtract, we get x to the negative third power. Notice these two problems are exactly the same, yet their answers are completely different looking. However, they are the same. If you have a negative exponent, again, you are going to simplify it by taking the reciprocal. There'll be more examples on the next slide. A zero exponent is the easiest to remember. It means anything that's raised to the 0 power is equal to 1. So if we had 1,000,000 to the 0 power, that's equal to 1. So here's the proof. We have x to the 5th divided by x to the 5th. If you subtract using the quotient rule, we have x to the 5 minus 5, which is x to the 0 power. If you do it the original way, where you're just simplifying, you expand the numbers, you're canceling what they have in common, and you'll notice all of these things are canceled out. Well, x divided by x is just 1. Therefore, x to the 0 power is 1. So, here's a quick review, and here's some examples that I'll solve for you really quickly. An example 1a, x to the third times x to the 5th. That should become x to the 8th power times y. Notice we are not combining the x's and y's because they are not the same base. For b is a little bit tricky, so I wanted to make sure we showed it to you. What we're doing here is if you only look at the exponents, we have x to the second power, y to the first power, the whole thing to the third power. So really have a power to a power. That means what we could do is we have x to the 6th power, y to the third power. And the reason why that works is because we are basically distributing this 3 to each exponent. And notice the y is to the first power because there's only one y. If it was 0 power, that means it'd be 1. So this is how we do this. Part C, we're again using the quotient rule. So 2 answers would be considered correct. X to the negative third power would be considered correct. And 1 divided by x to the third power would also be considered correct, depending on what we ask for. If we specifically say without using negative exponents, this is the correct answer. So D. D is a simple one, but I want to make sure we touch on it. Notice that we have a negative 3 as our exponent. So the way that this works is we automatically take the reciprocal. So the easiest way to do this is to start off with, if you have a negative exponent, draw a fraction bar. Then you go through each variable and determine whether or not it stays or moves. Because the x exponent has a negative, or because the x exponent is negative, that means it moves. So that means this is x to the third power. Notice we moved it from the numerator to the denominator. And because you can't have you have to have something on the numerator, we just put 1. So that would be your simplified answer. Example 2 has 2 very similar problems, but I want to make sure that you see the difference. This negative 2 to the third power really means negative 2 times 2 times 2. Notice there's only one negative that's shown because only the 2 is being cubed, so that's equal to negative 8. In the example below, the whole negative 2 is being raised to the third power. So that's really saying negative 2 times negative 2 times negative 2, which in this instance actually turns out to be the same thing as negative 8. But they're 2 very different problems. So this one should have read 1,234 to the 0 power. When you raise that whole thing to the 0 power, you should know that it's just equal to 1. Let's look at example 3. Example 3, we'll run through quickly. Again, we have a power to a power because you'll notice that there's no second variable, and we have another power. So we're going to distribute that power to each piece. That gives us 3 to the third power, x to the sixth power. We do have to simplify that. 3 times 3 times 3 is 27, x to the sixth power. Let's look at part B. This time we have 2 things that we're multiplying. So when we do those, it should be pretty simple. You go piece by piece. So the first thing we're going to look at is the coefficients. Those are the numbers in front of the variables. So we have negative 5 times negative 6. Negative 5 times negative 6 is 30. X to the 4th times x to the 7th becomes x to the 11th. And y becomes y to the 12th. Let's look at C. C, notice we have a negative exponent already, which means that we have to start with a fraction bar because it's going to be easier to interpret. So again, we always go piece by piece. So the question should always be the same. Does this thing have a negative exponent? So does a 3 have a negative exponent? No. Therefore, it stays on the top. Does a x have a negative exponent? No, so that stays on the top. Does the y have a negative exponent? Yes. So because it has a negative exponent, that means we have to move it from the top to the bottom. So that'd be y to the 4th. Keep in mind that if the y were already on the bottom and still had a negative number, that means we would move it to the top. We'll do another example. Doing part D. Again, piece by piece. So we're trying to simplify. So we have 4x to the 0 power. So 4 I can't do anything with. X is to the 0 power, which means that's actually equal to 1, and y is still there. So 4 times 1 is y, or 4 times 1 is 4. 4 times y is 4y. E, now before you go through the whole thing and start solving it only to be upset later, notice that entire quantity, so this entire quantity here, is being raised to the 0 power. And because it's being raised to the 0 power, that means this 0 is being applied to everything. Therefore, your answer is only 1. Please make sure you're mindful of that because you are going to see that on a future quiz. Part D, simple. They're all simple. Just do it piece by piece. So again, I see some negative exponents in here. So I'm going to go ahead and start with a fraction bar. So here's our fraction bar. And we're going to start to simplify. So we have negative 30 divided by 10. Well, that's negative 3. And then we have a to the 14 divided by a to the 17. Well, that's a to the negative third power. So notice that I kept that negative third power there. We subtracted the top minus bottom, and we got negative 3. Now we have b. So b to the 8th, I'm going to do this slightly differently. B to the 8th is positive, so I'm going to leave it there. And we have b to the negative second on the bottom. So because we have b to the negative second on the bottom, that means it's actually going to go up to the top and become b to the second power. And notice we still have not touched that exponent yet. So, I'm sorry, we haven't touched the exponent on the outside, so we're going to go ahead and keep it there because we haven't done anything with it yet. Notice we still have a 3 on the outside. Now, again, I still see negative exponents, so again, we're going to start with a fraction bar and go through piece by piece. This should be much easier now. So we have negative 3, which does not have a negative exponent. We have a to the negative third power. So because a to the negative third power is a negative exponent, that actually means it's going to go to the bottom. And that's still going to be a third power. And b is going to be b to the 10th. Again, we still haven't touched the exponents on the outside, so we're going to go ahead and take care of it now. So now we're going to distribute this 3 to every single piece on the inside. Notice this exponent is being distributed to the exponents of each value, not the number itself. So this should now read negative 3 to the third power. B to the 10 times 3 is 30, all divided by a to the 9th power. I'll put our fraction bar back in there. And the only other thing that you have to do to it is have it become negative 27, because negative 3 times negative 3 times negative 3 is negative 27. B to the 30th, and a to the 9th. And this is your final answer. That's all for now. Now it's your turn. Solve problems 1, 2, and 3. Put these on your notes and we'll check it in class tomorrow. That's all for now. I'll see you guys next time.